Hello and welcome dear students. I am Shravan Sir, your maths lecturer. We have started the second topic of maths part 1, that is matrices. In earlier videos we have seen the definition, types of matrices and algebra of matrices. Today's topic is inverse of a matrix. Here onwards the real matrices starts. Now what is the inverse of a matrix means? Suppose A is a square matrix. Inverse of a matrix will exist only for square matrix. Square matrix means what? Having order 2 by 2 or order 3 by 3 for our syllabus. Two matrices 2 by 2 and 3 by 3 are known as square matrices, and for square matrices inverse will exist. Suppose A is any matrix, then its inverse is denoted by what? A raised to minus 1, and we will read it as A inverse. Inverse of A is what? A raised to minus 1, and we will read it as what? A inverse. Suppose B is another matrix, another square matrix, its inverse is denoted by what? B inverse, B raised to minus 1. Now what is the meaning of inverse of a matrix? Suppose we have two matrices, square matrices, and if we multiply these two square matrices and we get what I mean identity matrix or unit matrix. If the product of any two square matrices is what? A unit matrix. What is unit matrix? Whose diagonal elements are 1 1 and non-diagonal elements are 0. If the product of any two matrices is what? Identity matrix or unit matrix, then these two matrices are said to be what? Inverse of each other. Now B is inverse of A, which is denoted by what? A inverse. Therefore the formula becomes what? A into A inverse equals to I. Because A into A, if we multiply these two matrices, we will get what? Identity matrix. If we multiply A into B, we will get what? Identity matrix. Therefore B is inverse of A or A is inverse of B. Therefore by definition we have two formulae for row transformation. A into A inverse equals to I, where I is what? Any unit matrix or identity matrix. Column for column transformation, A inverse into A is equal to I. So to find inverse of a matrix we have two methods. First one is what? Adjoint method, and second one is what? Elementary transformation. In elementary transformation we have two methods, row transformation and column transformation. A into A inverse equals to I or A inverse into A equals to I. These are the formulae for finding inverse of a matrix using elementary transformation. Now for adjoint method we have the formula A inverse is equal to 1 upon determinant of A into adjoint of A. Adjoint of A means what? Adjoint of a matrix. We'll see soon. Now what is A inverse? A inverse will exist. A inverse will exist if the determinant, this is what mod A means, what? Determinant of A. If determinant of A is not equal to 0, means matrix should be non-singular. Matrix should be non-singular matrix. What is the meaning of non-singular and singular matrix? A matrix whose determinant is 0 is known as singular matrix, and matrix whose determinant is not equal to 0 is known as what? Non-singular matrix. So if we have 1 upon 0, then 1 upon 0 becomes what? Not defined. Therefore inverse of matrix will not exist. But if we have non-zero number 1 upon 2, 1 upon 3, 1 upon minus 5, then inverse of matrix will exist. So for finding inverse of matrix using adjoint method, the formula is 1 upon determinant of A into adjoint of A. Now we'll see what is adjoint, minus and cofactor of a matrix. Before we find adjoint of a matrix, we will see two concepts, minor and cofactor of a matrix. Minors and cofactors of a matrix. Minors are denoted by capital Mij. I stands for ith row and jth column, which is obtained by deleting ith row and jth column. The value of minor of Mij is the value of determinant, which is obtained by deleting ith row and jth column. And cofactor of Mij is denoted by Cij or capital Aij, which is given by the formula I minus 1 raised to I plus j into Mij. Let us take one example. Suppose A is a matrix whose elements are 1, 2, 3, 4, and we are asked to find minors, cofactors, adjoint of A and inverse of a matrix. Now what are the minor of for finding inverse of a matrix, first we have to find the determinant of matrix A, whether it is 0 or non-zero. If the determinant of matrix A is 0, then inverse does not exist. If the determinant of matrix A is non-zero, then inverse will exist. Now determinant of matrix A is what? 1 into 4, that is 4, minus 3 to the 6, so minus 2, which is non-zero number. Therefore A inverse exists. A inverse will exist. If determinant is not 0, then A inverse does not exist. Now how to find minors of the matrix A, and here we will find cofactors. Minors are denoted by M, capital M, and here we have 4 elements: A11, A12, A21, A22. Now minor of A11 is denoted by M11. Minor of A11 is denoted by M11, and this is the position of A11. And if we hide all the elements along this element, means the determinant obtained by deleting ith row and jth column along this element, the number obtained is known as what? Minor of the corresponding element. If you hide this element A11, then the number is remaining is what? 4. So 4 is the value of minor A11. Now next is M12. What is the position of M12, A12? A12, this is the position, hide this element, and the remaining element is what? 3. Next, M21. M21, this is the position of M21. So hide the elements along this row and this column. So element is what? 2. So M21 is the minor of A21. Next we got M22. M22, what is the position of A22? This is the position of A22. Hide the position of these elements along the row and column. So the remaining element is 1. So this is the minor of M22. So minor of any element is obtained by deleting ith row and jth column along the same element. Now what is the cofactor? Meaning of cofactor? First we have to write the definition: Aij or Cij minus 1 raised to I plus j into Mij. Now C11 is the cofactor of M11 or A11. What is cofactor? How to find Ij? Means what? These number are known as what? Ij. So minus 1 is fixed in the formula. What is the value of I and j? 1 plus 1. I and j both are equal to 1. And M11. I1 j is also 1. So the answer is minus 1 raised to 2 is 1. And what is M11 is 4. So final answer becomes what? 4. Now next is what? M12. M12. The cofactor is what? C12. So answer is minus 1 raised to I plus j, means 1 plus 2 into corresponding minor is what? 3. So minus 1 raised to 3, odd number means minus 1 into 3, so minus 3. Next element is M21, and the cofactor of A21 is what? C21, which is given by the formula minus 1 raised to 2 plus 1 into corresponding minor is what? 2. Here also odd number, therefore minus 1 into 2, that is minus 2. And the last one is what? M22, and the cofactor is denoted by C22, which is given by the formula minus 1 raised to 2 plus 2 into corresponding minor, that is 1. So minus 1 raised to 4 is 1 into 1, so answer is 1. So these are the minors and cofactor. Now what is matrix of cofactor? This is original matrix. If we write all cofactors in a matrix, then the matrix obtained is known as what? Matrix of cofactor, and which is denoted by what? Cij. C denotes what? Cofactor matrix. C denotes cofactor, and Ij denotes ith row and jth column. If we write all cofactors in a given matrix, then the element cofactors are 4. 1 2 is what? Minus 3. 2 1 is minus 2. 2 2 is 1. This is known as matrix of cofactor. It is Cij in bracket is known as what? Its symbolic representation. So Cij in bracket is known as symbolic representation of matrix of cofactor. Now what is adjoint of matrix A? Adjoint of matrix A is transpose of matrix of cofactor. Transpose of matrix of cofactor. Now what is transpose of matrix of cofactor? Transpose means what? Interchanging rows and column. So interchange rows and column here. First row is 4 minus 3. So it becomes first column 4 minus 3. Second row is minus 2 1. so it becomes second column minus 2 1. This is known as adjoint of a matrix A. So what is the adjoint of matrix A? Adjoint of matrix A is a matrix which is obtained by taking transpose of matrix of cofactor. Now what is matrix of cofactor? Matrix of cofactor is a matrix which is obtained by putting or by placing cofactors on the position of A11, A12, A21 and A22. Now what is the definition of A inverse? Now we have determinant, the value of determinant also, adjoint. So we can find easily that inverse of a matrix. What is inverse of a matrix? Formula is using adjoint method. A inverse is equal to 1 upon determinant of A into adjoint of A. 1 upon determinant of A into adjoint of A. Now what was the determinant? 1 upon minus 2 was the determinant, and what is adjoint of a matrix? 4 minus 2 minus 3 1, and if you multiply this 1 minus 1 by 2 in the inside the bracket, then we will get what? Or simply we can write minus 1 by 2, 4 minus 2 minus 3 1. This is the value of what? A inverse. Or you can do minus 2 multiplied by minus 2. This is what becomes 1. This is 3 by 2 or minus 1 by 2. This step also you can write. These both steps are correct. You will get full marks for both these steps. With this we have completed adjoint of a matrix of order 2. In the next lecture we will see the inverse of a matrix of order 3 by 3 by using adjoint method. Thank you.